Alright, in this video I'd like to go over homework questions number 19 and 20. So for number 19 it says, if the magnification of objects are as follows, what else can you say about the image? So what we're looking at here is, so if our magnification is negative, what does that tell us about our image? And if our magnification is positive, what does that tell us about our image? So to end up with a negative magnification, let's look at what our ways of finding magnification. So magnification is equal to the height of the image divided by the height of the object. So if I end up with this being a negative number, that means one of these has to be a negative number. So if I have something like a candle and a mirror, if my object is positive, to have a negative magnification, my image has to be negative. And now for my image to be negative, if this is my 0, that means my image would have to be upside down. It would have to be inverted. So it would be inverted, which means it would be also a real image. That's something we learned about in the labs, that real images always appear inverted. Now, vice versa, if we have a magnification that is positive, that means either both of these need to be negative or both of them need to be positive, which would mean, do this in a different color, green. So either both positive or both negative. So either both of my images are upright, or both of my images would have to be inverted. Which would mean, if they're both inverted, that means they are both, let's see what's doing green. They're both upright instead of inverted. They're both being reflected the way they are, which means it is a virtual image. Alright, and to help you understand that, I could say things here, I'll probably mess it up. I posted 2 videos in the in one of the folders, the resources folder on this chapter, and it has today's date on it, 4/29, about from Khan Academy explaining real images and virtual images, and he goes through how the angles reflect off the mirror and create these images that are either inverted or upright, and whether it's a real image or virtual image. So watch those, and if you still have questions, then let me know, and I'll try to go through and explain it again. Alright, so next, number 20. If you are standing 2 meters in front of a flat mirror, how far behind the mirror is your image? So we have our mirror here. Okay, and we are standing there with our right shoulder, and we're facing the mirror, and we are 2 meters away. So the question is, how far behind the mirror is your image? So if we take any point on our object, I'm going to take the right hand, let's see if I can do this in a way that kind of makes sense. So light from the room is going to be hitting off our hand, and it's going to be going out in all directions, but only some of those light rays are going to be reflecting off this mirror and coming back towards our eye. So I have one that's coming here, it's going to bounce off the mirror, and it's going to come back. Okay? Now that's also going to appear to go right through the mirror. I have another one that's going to come off here, bounce off the mirror, and come back towards my eye. And according to my view, I would view this as traveling in a straight line. It would appear that it came from, didn't draw that line very well, it came from back here inside the mirror. And it would meet right here. So this point is my hand. But according to my eye, it looks like it's way back here. And let's do this with another point. So I'll do it with my left hand. So again, it's going to go right in the mirror. It's going to reflect back and come straight back. But it's also going to appear to go straight back through the mirror. And again, it's a different spot than this one, so when it comes and bounces off the mirror and goes back up, according to what I see, it's going to look like it's coming from, again, drawing these angles freehand is a little difficult, but it's going to come from here. So it appears that it's there. And if I end up doing that with all of my spots, I'm going to end up with everything looking like it's on the opposite side. So my right shoulder, which is further from the mirror, would appear further from the mirror on the back side. But these parts that are closer are going to appear closer. And so everything is going to look reflected. Now, if I did all the math here with these triangles, which we could do, we'd get to the point where, well, every point that is closest to the mirror is going to appear to be closest to the mirror over here at the same distance. So it's still going to appear to be 2 meters away. And the further, it's not part of the question, but say this is, another half a meter, 2.5 meters over here, that's going to appear to be another half a meter over here, 2.5 meters over there. Okay, so but to answer the question, how far behind the mirror is your image? 2 meters. Now, what is the magnification? So we just talked about magnification over here in terms of the height of the object. I don't tell you what the height is, but we do know the distances. So magnification is equal to, if we look in our lab packet, it's equal to the negative distance to the image divided by the distance to the object. So let's get a little more specific here. If this is my positive 2 meters, measuring out from my mirror, this would then be negative 2 meters. Okay, so I guess we need to be more specific here, negative 2 meters. How far behind the mirror? 2 meters behind the mirror, negative 2 m. So I guess that wouldn't be negative because it's saying behind the mirror. So it's just words. But 2 meters behind the mirror. So in terms of measuring the distance of SI, the distance of the image, negative 2 meters, I'm going to have negative 2 meters divided by the distance of my object, which is 2 meters. So I get a magnification of 1. And if we go back to this question here, if I have positive magnification, it's not a negative number, that means my inverted real object is, my upright real object is also an upright image. So I have a virtual image, positive 1 magnification. And then where is the image's right side with respect to your right side? So we look at it, the right side of our image, which is on the left here the way I drew it, because I'm facing the mirror, is on the opposite side. So I'm just going to write opposite just to make it a little bit clearer. It's just on the opposite side. Everything's reflected backwards. Okay, because we have a virtual image here. It's an image that appears inside the mirror. So hopefully that helps a little bit with number 19 and 20. I'm going to do another video in a little bit here about questions 21 and 22. If you have other questions, please let me know, and I'll make some more videos about those.